Hello guys, you're welcome again to my channel. And today I am going to discuss the IPv4 IP addresses, the classes, and how you can be able to identify IP classes. This is very useful because in my other video, I have already explained the real life situation of subnetting. Understanding IP IPv classes are very useful when it comes to network and IT infrastructure. And so today, let's dive deep through how we can be able to identify the IPv4 version IP addresses. Now, I'm going to share with you again my screen, a whiteboard. And now the IPv4 IP addresses space, there are 5 classes of this IP version 4. Now we have, for example, we have 5 classes of these addresses, and so we have class A, class B, C, D, and E. Now we're going to look at each of these classes, how we can be able to identify each of these IPv4 IP classes. Now, each class has a specific range of IP addresses. It ranges for a certain values or for certain IP addresses, and it automatically detects the numbers of hosts that can be hosted on a network or a subnet. Now, primarily, classes or class A and B and C are used by majority of devices. These 3 classes are majorly used by devices, which we will dive better and deeper into today. But for the class D and E, it is not used because they are specially used because they are reserved IP address for other networks. Now, let's start with dealing with class IP version. Remember, we're dealing with IP version 4. Now, of course, IP version 6 is another entire topic when it comes to IPv. Now, IP version 4 has 8-bit, as we know. They have 8-bit in IPv version 4. But today, let's not just get ourselves mixed up with considering what an IPv version 6. In our next video, likely we will deal with that. Now, looking first at the class A. Now, the class A addresses are for networks with extremely huge numbers of total hosts. Now, the class A, this class A address starts within a range, as I already mentioned, starts within a range of IP address ranging from 1 till 126. Now, any IP address that falls in this range are considered as a class A IP address. The IP class A address can host as many as 16 million host computers on its network, or even 17 million approximately. A class A network numbers values, as we already mentioned, between 1 to 126 or 127. Now, I just wrote 126 because I think I was always considering the last IP address for the network. So it ranges between 1 to 127. Now, for example, an IP address, an example of an IP address class A is what we have. For example, we could have an IP address of say 26.20.10.0. Now, how do we know that this is a class A IP address? Now, how we know is that the first octet here, of course, not the octet, but the first IP range address is what determines whether this IP is a class A or another class. Now, as we already considered that the class A is from 1 to 27. So it means that this IP address, its range, it's a class A IP address. Now, another thing that you must consider in in an IP address is its subnet mask. Now, this subnet mask is very important when it comes to subnetting. Now, the subnet mask of an IP address is used to determine the number of subnet, the number of hosts, and that this IP network or this or a network can host in a certain subnet. For example, you might have seen something like this. Now, for a class A IP address, you have an example of a subnet where the first octet is filled. The first octet of this IP address are filled. Now remember, when it comes to IP address, we have 8 octets in the IP address. 8 bits. It's made up of 8 bits. Now, if we remember, if we are talking about 128, 62, or 64, sorry, 32, 16, 8, 4, 2, and 1. Now, these are 8 octets or 8 bits that makes up the IP version 4 address. Now, for an IP class A, the first octet for its subnet marks are completely filled. Now, because if you add all of these together, it's going to give us 255. So the first octet is filled because it has 4 octets for the subnet mask. Now, the first octet is filled while the remaining 3 octets are in zeros. Now, this is an example of a class A subnet mask. Now, this means that when we are transcribing this into binaries, now it means that all of the first octet, now why we are saying all of this first octet are filled is because this whole bit makes, when added up, makes up 255. So which means that we have, for this in the binary form for this subnet, we are going to have 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7. Am I correct? 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Now, these are very important. Now, in my other video where I did how a real life situation of subnetting, you will see the importance of understanding the subnet mask and the binary or bit for the subnet. Now, for a class A IP address, we have the first octet completely filled. Now, you might wonder, or you might ask, how did we arrive all at this one and all of these are 0? Now, the first octet is completely filled with 255. Now, because 128 plus 164 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 gives us 255. Now, but what about a situation where we have, let's erase this. What about a situation where um, we have, we have 248, for example. Now, this is 248. Now, how do we, I'm just using this to show you an example of how we arrived at a complete octet for this IP class. Now we have 248. Now we are going to add, look for something that we will add here that will make up 248. Now we have 128 plus 64. That is already 192. Now when we add this plus 32 plus 16, it's 1 plus 8. Yes, that's it. So this whole is already 140 plus this 8 would be 148. So now what makes up 248 in this bit are 128 till 8. Now it means that for these 8 bits that we normally have, because we have all of these making up 248, we are going to have one that's for 128, another one for 64, another one for 32, another one for 16, another one for 8. Then because 4 was not inclusive, to make up 248, it becomes a 0, 0, 0 for 4, 2, and 1. Now, this would be what the binary bit for a MAC address or a subnet mask ID for 248.0.0. So it means that this would be replaced. Let's erase this and replace this in the situation. So for this, for example, it means that this will be 1 because we have 1, 2, 3, 4, 5. So it means we already have 4 here, 5, 1, 2, 3 dots. So in this subnet mask, this is exactly what we will have. Now, this is an example of a class A subnet mask and IP address. Now, you might ask again, what of a situation where we have, let's consider a situation like this, where we have a quite, how do we know? This is an exercise. Take 1 minute to think of this. Now, so far what we've talked about, what IP address class would this example, this IP be? 16.7.27.27.8. Now, what class of IP address would this be? Now, this is also a class A IP address. Now, very good. Now, let's move on to the next class, the class B IP address. Do not forget, the class A IP address can cover or can host more than 16 million hosts on its subnet. Now, let's consider the class B IPv4. Now, the class B IPv4, of course, also covers a wide range enterprise or also hosts a wide range enterprise for any network. It's it allows it could allow for roughly around the class B can allow as much as 64,000 hosts, 64,000 hosts on its subnet. Now, what is the range of this class B? Now, the range of this class B can would start from 128 to 191. Now, this is the range of a class B IP address. Now, an example of a class B IP address is, we have an example of 130.2 27.10.10. Now, this is an example of a Class B IP version 4 address. Remember, this address can host more than 64,000 or approximately 65,000. So approximately 65,000 hosts on its subnet. And it depends, or it also depends on the subnet mask and how or what subnet mask we're using. That depends on the subnet that we would have in such a network. Now, a situation like this, we have for a Class B IP address, 16 octets are completely filled for the subnet mask. Now, I remember for a Class A, we only have the first 8 octet, which is the 8 bits are totally filled. Now, for a Class B, the subnet mask, the first 2 octets are completely filled, leaving the rest with a 0.0. Now, so for an IP address of such would have this address. Now, the interesting thing is that um, when you are in the real life situation and you are trying to configure a router or a switch or whatever, and you input this IP address, the router, for example, automatically understands that this IP address is an IP class B, and it automatically assigns a subnet mask to this IP address because he understands that this is a class B and automatically assigns this. Now, then how can we then do subnetting when we are doing subnetting? This, of course, is already I showed in my other videos. If you want to watch my other video on a real life um, situation of subnetting, when you are asked for in a company as a network engineer, you are asked that you should subnet 600 host computers for a new branch. How do you go about it? I would have asked you to watch that video after you must have understood all about IP, and subnetting. Now, what this means now for the Class B is that the 16 bits are totally occupied, meaning that the first 2 octets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, did I say 10? Sorry. So we'll take 2 out. They are always 8-bit. Remember, these are basics that 8 bits make a byte. Now, so it means dot 1, 1, 1, that is 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0. That's 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Very good. So now for a B class IP, this is the bit. This is what we know as the bit for this subnet mask. Now, these are very important when we understand how this works. Now, remember, the first 2 octets for the subnet are completely filled for a Class B IPv4 IP address. And it can cover or it can host as much as approximately 65,000 computers or hosts on a subnet or on the network. Depending also on the subnet mask will tell how many subnets can this subnet mask host as well for us. Now, I think this is a little information about the Class B. Now let's move into the Class C, which is most popularly used in the world today. Now, the Class C are used in a small local area networks. I think most businesses use this. The Class C, most business uses the Class C public IP address because it can host to an approximately 255 hosts or computers on the network. And so, because of this, I think most companies are below, for small companies, they are below 255. But for enterprise companies that have staffs or that have users um, in their whole network for more than 600. I remember a company I worked here in Germany had a 600, more than 600 client computer for just one branch. And so such a company definitely would not use um, a Class C IPv4. And so obviously such a company using 600, above 600 to 800 would fall to a Class B IPv address. Now uh, for a Class C, as we've just considered, for a Class C, 1 minute, please. I think I just lost my pen. Uh, okay, got it back. So for a Class C, now, and as the range of a Class C address, the range is between, remember where we ended at Class B was 191. So it starts from 192. Now that's the range for a Class C. It ranges from 192 till 223. Now for any IP address that falls in this range are a Class C IP address. For example, when we see, I think we are very familiar with this IP address, which of course is the um, external gateway that's for most or major ISP internet service providers, where we have 192.168.10.0. Now, such an IP address is in a Class C because of this first octet here, of course. Now, for the subnet for a Class C, the first three subnet are octet, or the first three octet are completely filled, meaning we have 255, 255.255.0. Now, let me confuse you a little. Let's brainwash you a little. Now, if I have this subnet mask, now, in some case, what if I tell you, I give you this IP address? Now, let's change the color. What if I give you, um, let's change it to blue. Now, what if I give you this IP address, and I give you the subnet mask of 255.255.248.0 or .248 or 192. Okay, 192 dot. This is 9, please. I just take it out. Good. So 192.0. Now I'm asking you, what class? What class is this network? What class do you think this network still falls on? Do you think it falls on a different network? Not at all. It falls The IP address is what determines the class of that network, not the subnet mask. Do not get that confused. So it is the IP address, the range of the IP address, the first octet, that determines if this subnet mask is a class B or should be a class B or a class C. And so no doubt this is a class C, as we know from the IP address. Now, I already mentioned that the Class C hosts computers of approximately 255 hosts on just one network. And as we already considered, that the whole octet, well, 3 octet are completely filled. So for such, we have 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1 dot 0, 0, 0, 0, 0, 0. Dot 0. Now for this IP address, this is the bit for this subnet mask. Sorry, not IP address. This is the bit for this subnet mask, as we've already considered for a class B. Now, I think the most important thing is to be able to understand how this bit are with the subnet mask, the range, and these are most important key points not to forget when we're dealing with IPv4 classes. Now, let's look lastly at the IPVD, that is the class D. Now, as already mentioned, the class D are not allocated to hosts. This is one thing. The class D IP address The Class D IP address are not allocated to hosts. They are not assigned to hosts. They are reserved for special purpose, and so they are not used for multicasting. So they are not used for multicasting at all. They are not used for subnetting or otherwise. So the Class D. Now they range from 224 to 239, and the first the first octet value are, as we already considered, are in this range. And so, for example, an IP address of 228.220.8.2 is an example of a Class D IP address, and uh, uh, it's a subnet. It's subnet mask. The fourth, the entire subnet mask are, are completely filled. So it has a subnet mask of 255.255 um, dot maybe 228 or thereabout, something of this. And so they are not often used, of course, as I already mentioned, they are not used for multicasting, and they are not used. They are not assigned to a host, or they are not even used. They are not given to a host in a network. Now, a similar thing is also with the Class E. The Class E ranges from 240 to 255. They range from 240 to 255, and so for uh, they are also majorly reserved for this IPv4. They are majorly used for experiments, and they are reserved for research and um, I think for research purposes, this is what this IP version E are used for. So the D, the D IP version, IP class D and E are not used uh, in in the industries. Now, now, of course, that understanding what understanding these classes of IP address can definitely go a long way to understanding more on subnetting. Now, so far, we've been able to see that IP addresses can be classed into 5 different classes, and we are able to discuss the range and also the number of hosts and also the subnet alongside with this IP addresses. And so it's quite interesting that we want to use this practical knowledge that we've gained, or this theoretical knowledge, to improve our practical skills. And how can we do this? We want to start to do subnetting with this knowledge. And of course, this is not all you need on subnetting. I still have a video that helps you to calculate um, uh, how to find subnet, how many subnet and how many hosts that are found inside the network. And there is another video still that talks more also on what is the difference between an IP address, a subnet mask, a network ID, a broadcast ID, and all of these and so on. So I hope you subscribe to my channel, and please do not forget to like and share. And hope to see you again. Please have a wonderful day. Thanks for joining, and bye.